All right, let's dive into something we use literally every single day, but maybe don't think about all that much. In this explainer, we're going to answer a pretty basic question. How in the world do batteries actually work?
I mean, seriously, have you ever just stopped and thought about it? You pick up your phone, tap the screen, and boom, it lights up. It feels like magic, doesn't it? But really, it's just some incredibly clever chemistry happening in a tiny little box.
And right there, that's the first big idea we need to get straight. A battery isn't like a little tank full of electricity. Not at all. It's a device that's been perfectly engineered to create a chemical reaction whenever you need it to. That reaction is what gives you power.
So to really understand this, we've got to peek under the hood. Let's zoom way, way in and meet the three main components that make the whole shebang possible.
First up, you've got the anode. This is the negative side of the battery, and you can think of it as the starting line. Its entire job, its whole reason for being, is to give away these tiny little particles called electrons. Just remember that negative sign, it's super important. And on the other side of the ring, we have its total opposite, the cathode. This is the positive side, the finish line. If the anode is dying to get rid of electrons, the cathode is over there just waiting to scoop them all up. And sitting right between them is our third key player, the electrolyte. Now, the electrolyte is fascinating because it's kind of like a bouncer at a club. It's this chemical goo that lets other charged particles, called ions, pass right through. But for the electrons, nope. It's a total roadblock, forcing them to go somewhere else. So, we've got our three parts. Now let's talk about how they create this amazing tension that is the whole secret to a battery's power. And this really lays it all out, doesn't it? It's that classic saying, opposites attract. The anode is the ultimate giver. It's packed with electrons it just wants to get rid of. The cathode is the ultimate taker. It's got plenty of room and a powerful urge to pull those electrons in. And that difference, that chemical push and pull between the two sides, is what creates something called electrical potential. It's basically stored energy. Think of it like a tightly coiled spring, or water held back by a giant dam. The energy is just sitting there, waiting for you to let it go. So, now for the fun part. How do we actually unleash all that stored up energy? Well, we have to give those electrons a path to travel on. And that path, that road, is the circuit inside your phone. This is really the heart of it. Remember how that electrolyte acted like a wall for the electrons? Well, that was totally on purpose. It forces them to take the scenic route, this superhighway that just so happens to go right through all the electronics of your device. Okay, let's walk through it step by step. So first, the anode pushes its electrons out into the circuit. Now, at the very same time, to keep everything in balance, those ions start moving through the electrolyte. Then the electrons zip along that superhighway, powering your screen and your apps. They're doing work. And finally, they reach their destination, the cathode, which welcomes them with open arms, and the circuit is complete. And that movement, that complete journey of electrons from the negative side all the way through your device to the positive side, that is an electrical current. That's what electricity actually is. It's the flow that powers our entire world.
Okay, let's zoom back out for a second and really nail down the big central idea of what's going on here.
This right here is probably the biggest thing people get wrong about batteries. They don't store electricity. When you charge your phone, you're not pouring electricity into it like water into a cup. You're using electricity to reset that chemical reaction, storing energy in a chemical form.
So the moment you turn your device on, you're giving that chemical reaction the green light. The electrons start to flow, and right in that moment, that stored chemical energy gets converted into usable electrical energy. It's an energy transformation happening on demand. So let's boil it all down one last time. The anode gives electrons. The cathode takes them. The electrons have to travel through your device to get from one to the other, which is what creates power. And this whole beautiful dance is just converting chemical energy into electrical energy. Pretty cool, right? It's such an elegant system, but, it just begs the question, what's next? The huge race right now is to find new materials, new chemistries for that anode, that cathode, and that electrolyte to make this whole reaction even stronger, faster, and last way, way longer. That's the challenge that's going to power our future.